Elkins with Industry Network Technology Council. We are doing our third session in our IPv6 training classes, IPv6 Neighbor Discovery. This session is being recorded, and so you will get the recording as well as the foils after the session. If you have any problems hearing or seeing the screen or anything, do let me know. And in fact, if somebody can send me a quick note from the questions panel to let me know, then that will be good. Yes. If you have questions, go ahead and send them in the questions window. So yes, please, as I said, let me know if people are hearing me okay. Yes. Are you guys hearing me? Okay, great. Thank you so much. I don't want to go on if people aren't hearing. Okay, perfect. Okay, all right, so let's go ahead and get started. So this is a collaborative project, this whole idea of training up on IPv6. It's a collaborative project between a number of organizations, which, of course, the Industry Network Technology Council in the United States, the India Internet Engineering Society in India, and this particular set of sessions is being funded from ISIF Asia. Thank you so much to them. And you can see our websites up there. Our vision is to have a multi-year project. And the idea is that we will have IPv6 deployment at enterprises. And we'll have some discussions at the end about how, if you want to get more involved, how you can do that. We are also collaborating with the American Registry for Internet Numbers, or ARIN. We have a grant for various things with them. You may have seen some of our emails about that. The idea is that we'll provide training, and then we'll look at some areas which may start causing you problems, or which people have a lot of questions about, and that is security and application conversion. You know, what I do, I make a little bit of an analogy to if you're buying a house, then the first thing you might want to look at, well, or one of the first things is, you know, is the plumbing okay? Am I going to get into trouble with rusty pipes and going to be having to replace them? You know, are the appliances all okay? Will I run into a bunch of expenses to replace them? Things like that. So that's the idea. Let's look at what might really start causing us problems. And then, of course, we want to help enterprises to plan their deployment. But, you know, one of the things is that it's really up to you. Is every network is different, and so there's not a cookie cutter approach. So what we want to do is help you get the concept. And you know, so you can go ahead and do things yourself and provide a support group, if you will, so that you know, we can work together towards this goal. To that end, we have quite a few classes planned. This is the third in the session. The links to all the other classes and the recordings are up on both websites. Please go there for that. Those are always available. So just a few words about me. I'll keep this short. I am the president of INTC. I also have a for-profit company, Inside Products, and I'm on the advisory board of the IIESoc, the India Internet Engineering Society. The RFC 8250 and some other RFCs. I've co-authored those. I'm a product developer. That's what I am. I'm a coder. And I've been working with IPv6 for a long time, and also working with brick and mortar enterprises. So all of this is focused very much on the needs of very large enterprises, what they need. It's a different perspective. You know, things can get very, very complicated when you're dealing with large enterprises. So let's go ahead and start. Why are we talking about neighbor discovery? Well, because it's one of the things that has really changed in IPv6. Last time we talked about addressing. So what neighbor discovery and the other protocols that are around it, router discovery, multicast listener discovery, the whole idea of this is forget ARP. This is how you're going to get an address. If you just, remember in IPv4, we used to have the address resolution protocol. Well, do an erased memory on that. That is no longer how we're going to get addresses. We're going to do it a new way. And because it's so new, that's why we want to dwell on it and, really cover it in detail so you get the concept. And a lot of this is done through Icmp V6 messages. Icmp has changed dramatically. And it's in effect its own set of protocols. It's a little different. We're not quite used to this in IPv4. So let's slow down and really take a look at how all this has changed. So we'll go step by step. And as always, we will look at packets. And then in the next lab session on March 18th, Michael and I will run through and show you neighbor discovery in action and look through a lot more traces. As I say, packets don't lie. That's how you really know what's going on. So why do we need to talk about this in terms of your network? Well, you can do address configuration in either stateless mode or stateful mode. Stateless mode, if you think about it as essentially plug and play, you'll hear it talked about as Slack. That's very new in IPv6. And of course, plug and play sounds very, very attractive. It's like, sure, I'm just going to plug my device in and magically it's going to get an address. Well, great, but what address did you just give that device? And you may not want every device to get an auto-configured address. You may want some static addresses. Do you want all your servers to have different addresses all the time? Maybe not. And so you may want to have a combination of DHCP V6, which can give you stateful addresses. If you think about it in some ways as static-ish versus plug and play, that's not a bad way to think about the difference. Although, it's, as I say, as with any analogy, it does fall down. But let's discuss. If it's a start at a concept. We also need to think about address planning, another session coming up, and security planning, which is around privacy, topology, and potential new attacks. A number of the new attacks are in the whole neighbor discovery, listener discovery area. So the more you really understand that, the better off you will be. So let's think about addressing again. Let's review our link local unicast address. Anything which is IPv6 capable, any interface which is IPv6 capable will have at least one link local address. And that address is used to communicate on link with other devices. Link local addresses are used in neighbor discovery. So this is a little spoiler alert. Who are your neighbors? Well, your neighbors are folks who are on link with you. So you're going to use your link local unicast addresses to talk to your neighbors. And that's important is to know what your link local address is. Your link local address is going to go to the other side of your LAN segment. If you're an IP you can't cross the router boundary. So it's limited your router. If you want to cross the router boundary, you're going to need a global unicast address. We went over this last time. So stateless auto configuration is that it can give you both a link local and unicast address, one possibly, as can DHCP V6. Can give you multiple global unicast addresses too. But as I say, let me not precede that. Global unicast addresses to review are what you need if you want to go to the other side of your router, or of course, if you want to go on to the internet. So how does stateless auto configuration work? Well, so it's, as I said, it's going to give you the link local and global unicast addresses. You've got to have the link local first. And so how exactly is it going to do that? Well, the first shot that the IETF did at giving IPv6 link local addresses was to use the MAC address of the adapter. So let's look, for example, so I have a Windows PC and I have the result of the IP config there. And what you're seeing is the physical address of this network interface. And you're seeing 0011, dog 8, et cetera, et cetera. And so let's take a look. Let's take a look at what the link local address is. Well, you know what? I'm seeing this. I'm seeing a 11. I'm seeing a dog 8. Hey, that looks an awful lot like what I see up there. I'm seeing a 39292B. Oh my goodness. That is my MAC address right in there. And they've kind of smushed this FFFE in there for some reason. That looks an awful lot like my NIC address. Well, there's a lot of good reasons to do that. One, to ensure uniqueness. You don't want to have people having the same link local address. I mean, that would be very confusing for everyone. And so that was the first shot around. I will go on into what the next shot around was. But basically, you'll get the first way around, you get the MAC address of the adapter, get your link local address, and then you start talking with your IPv6 router to get some more information. And I'll tell you about that. And then you start joining your multicast groups. So let's follow this forward and see what am I going to talk to my router about? And what if I don't have a router? What's that going to do? So the link local address is at the level of the TCP/IP stack. If you have IPv6 enabled on your host or on your whatever that host is, cell phone, whatever, you're going to have a link local address. That's the responsibility of the IP stack. To get something else, you're going to need your router. But just within the stack itself, there's going to be a number of things that you do. The first is your duplicate address detection. So once you establish your MAC address, or however you do your link local address, then you ask everyone who are your neighbors. And who are your neighbors? Everybody that I am on link with. And you say, do you have this address? That's what I'm going to be using. Is there anybody who also has this? Now, of course, if you're using MAC addresses, that's going to be quite unlikely. But we have now changed to be using random numbers You could also change your MAC address so that it was random. And in fact, there is a whole lot of discussion going on at the IETF and other places about randomizing that MAC address. I believe you could have done that in any case, but I didn't really see that. I didn't see that many people doing that. But as I say, nowadays, life is very different. A lot of people are randomizing that MAC address. I mean, that has its own issues, but as I say, we'll leave that for another day. But this whole business of do you have this address that I am about to use? How is that going to be communicated? Well, you're going to be sending out some Icmp V6 messages. You're going to be sending out neighbor solicitations, neighbor advertisements, and so on to figure out, this is, does somebody have this? Now, already you may be thinking to yourself, well, how many am I sending out? Is what's going on this land segment? And so you can see that you need to be thinking about potentially chatter and performance implications of some of this. As I said, I just want to put that in your brain about some of the things with neighbor discovery. And of course, let's talk about security. What if I'm a creep and I say, well, I want to use this address, and then, everybody says, no, that's okay. And you're like, well, no, I've changed my mind. I want to use something else, something like that. There's a number of security things that can happen. So this whole area brings up some new problems for us. And in the lab, we'll show you how you can start looking at your neighbor discovery tables and so forth. So let's keep going. We haven't even gotten past our link local address yet. But there's a lot just even right there. So the next thing you want to do is like, well, sure, if I just have my link local, I'm only communicating on link. I mean, I would really actually, like to go to the internet or on the other side, communicate with other people. So then you've got to have a V6 enabled router. So then you start communicating with your router. And again, it's going to be Icmp V6 router advertisement, router solicitation messages. So that's and we'll look at a lot of those. So, but if you think of it that way, then it's starting to make a little bit sense. If I were you, and if you're just getting started into this, those four messages, the neighbor solicitation, neighbor advertisement, router solicitation, those messages would be the ones I would really concentrate on becoming familiar with. And so we'll talk a little bit about, well, what are you talking to this guy about? So what is this router going to tell me? So what you're going to do is you're going to say, okay, router, so on our network, what do we do? That is, do we do stateless autoconfiguration? Do we do DHCP V6? I mean, how are we getting our addresses? And the router will tell you that. The router will say, look, on our network, we're going to do stateless autoconfiguration. And so then you go, okay, fine, got it. Well, that's how we're going to do it. And we'll talk some more about what exactly is in those router advertisements and what information is sent back and forth, and in fact, look at the packet. So think to yourself too, though, what are we going to need? What are we going to need? We're going to need the network prefix for this global unicast address, and we're going to need a device identifier. Who are you probably going to get the network prefix from? Well, I bet you I'm going to get it from my router. And then I'm going to have some way within the stack to know what my device identifier is. So if you're thinking in terms of separation of function, then that's kind of what we're talking about here. The stack is going to be dealing with how are you going to get that back part, and the router is going to tell you what is the front part. There's a lot of advantages to Slack. Don't get me wrong. I mean, Slack can be wonderful in a lot of different situations. And you probably want to use that on your network in a controlled way. Now, let me give you, this is Nalini's opinion of how to do network design, because, you know, and take it for whatever that's worth. So the reason I'm saying that is that you don't have to deal with DHCP. It's quite easy to manage, and if you've got mobile devices, if you've got sensors, things like that, or you think maybe someday you might, then you can be set up to do that. The reason I say that you may not want to do it for everything is you've got servers too on your network. You've got things that you want to have fixed addresses. You may also wish to use a combination of DHCP and stateless auto-configuration. That might be very, very good. One of the real advantages to IPv6 is that you are no longer limited to one IPv6 address per interface. Let me give you one simple example. One thing you might want to do, for example, is say, look, this is the address that I want to use for going over the internet. And I'm going to change that a lot. And I don't care what that is, because because it's going to change all the time, and I don't want it to be tracked back to me anyway. But within your own enterprise or to certain business partners, you may want a fixed address from DHCP V6, which can go through multiple layers of firewalls. You know, and so as I say, that's just a simple example. When we get to address planning, we can talk a lot about that. You need to have Slack as one tool in your toolkit. So let's talk a little bit about the whole thing about the interface ID. Remember, I said the whole way we get that has changed, and it's because of that whole MAC address business. Is when you've got that MAC address embedded in there, a lot of people felt like, well, you can track me. The MAC address actually is split out into two different sections. There's the OUI field plus that FFFE plus the serial number of the MAC. Let's talk about this a bit more. So what is the issue? Well, if the IID is constant, then what people can do is say, well, I know exactly which interface you're coming in on, and I can track your activity everywhere, you know, all across the web. I can also probably, depending on if you're using different kinds of mobile IP, depending on, as I said, it's a little advanced topic, I may even be able to geolocate you. And so that's a lot of tracking and correlation people didn't want. Now, true that people can do this at different layers also. That's a whole different question. Let's just stick to the IP layer. So the other thing about OUIs is that the IP address of all hosts by the same vendor, but give in a particular time frame. Let's say that, you know, the vendors could be bought by someone else and so forth. So for example, you can say that here's some sample OUIs, and it's very easy to get those. Just go up to IEEE and get this. This is completely public information. And honestly, a lot of people use this. I do. You know, it's very useful to know, is this a Cisco device? Is this a Canon printer? I mean, what is it? And you can tell very easily what the device is and who's making it. The other thing it does is that if you want to do scans if a ping scan to see if you got a live device, if you're a hacker, and if you see that you're using this particular OUI, if you say, well, looks like you're using a bunch of Cisco equipment, well then, you know what, when I do ping scans, I'm going to put that in as the initial part of the address, and that dramatically lowers my search space. Because if you bought one device from Cisco, quite likely you've bought others. And so you can see why people felt like, well, maybe there's some exposure here. And so what people can do is they can take that underlying hardware address, because it was felt to be leaking device information. You know, on my home network, you know, I can tell, you know, if I'm at home and if I'm seeing HP, well, it's probably my printer. If I'm seeing an Apple, it could be my iPhone, my daughter's iPhone, or one of our laptops, you know, that's a little, but you know, but it's one of those kinds of things. So you can tell very quickly what you've got here. So what are people doing? They're doing anonymous addressing or IPv6 privacy extension. And so the addresses change all the time. Whereas the problems that comes up with is how are you going to diagnose problems? There's also implementation differences between the host manufacturers. Apple may have implemented it one way, Microsoft another way, etc. There's also questions of how do I diagnose problems? If somebody says, well, this is my IPv6 address, if you can get that far with them when you're talking to the help desk, but that was the address they had yesterday. And who knows, it's a completely different address today. So these are challenges that we have going forth as to how are we going to do all this kind of thing. But privacy extensions are being used everywhere. They're being used all the time. And your stateless auto configuration will give you, or can give you, both a private address and a static address. Depends on what exactly you want to do. So, yeah. So here we go. Here's my thing on network management. I always come back to network management and diagnostics because that's basically where I live, and I bet a lot of you live there too. And so how are we going to figure out what this whole thing is? And let's leave that for a different session. This is a long story, but as I say, again, another situation where you may wish to use both SLAC and a DHCP V6 in a controlled way, and private addresses and static addresses, again, in a controlled way. So I had to put this out. I had to put RFC 8064 in. So this is the reason I put this in is you may want to go take a look at it. But I will say that one of the things we try to do in these classes is translate RFC talk into things that normal human beings can actually understand. This is basically saying a lot of what I've been talking about. And so you can go up there and take a look at that. So let's start looking at some screens, okay? So what am I showing you? I'm showing you an old screenshot of Windows XP before any IPv6. Remember you used to be able to get some stuff like that, as this is just IPv4. And the IP config just shows IPv4 addresses. When I do my IPv6 install, that is going to start the SLAC process. And remember, where does Slack start? It's going to start on the host. It's going to start on the host. And so what am I going to get? Well, looky here. What did I get? Well, I got an address that now starts with FE80 and then something, something, something. So I can see that what do I know? That IPv6 installed correctly on my end host. What else do I know? Well, I also know that I probably do not have an IPv6 router that is connected to this. Why do I know that? Well, because if I did, I would also have gotten a global unicast address. But if I'm seeing just a link local, just something that starts with FE80, I don't have anything else. Let's talk a moment about some of these other things. As I say, this is quite old. You used to have a lot more of these. Teredo Tunneling, ISOTAP, which I believe this is the automatic tunneling. You can see that you've got link local addresses for those as well. We will talk about transition techniques in an upcoming session because there's a lot of transition techniques, and we do need to consider the transition techniques, when we're doing it, because that's another toolkit, another thing in your toolbox of where you might want to do tunneling. So now let's look at another screenshot. Okay. So what am I seeing here? Well, okay, what do I know now? What do I know? Well, so I've done my IP config, well, and I have my link local, grand. Well, and looky here, I have my default gateway. What is my default gateway? Well, that's my router here. So it's my 192.168.1.1. But when it's IPv6, I'm talking to it over this link local address. So that is the link local address of my router. Grand. But now let me look here. It looks like I've got an IPv6 address too. But no, I've got two IPv6 addresses. Interesting. Let's look at this first one. So this first one has 211 dog 8 FE39 292B. Hey, look at that. That's that same MAC address. That's that. Let me highlight that some more. This is, for heaven's sake. That's the same MAC address that we said that we didn't want. Is that whole same that MAC address thing? Because now people can track me. But this is an old device, and so it was still doing it on the old way. And so, but you can see now that it looks like I've got another global unicast address as well. And so I have to think, how did I get this one? That's an interesting question. We'll talk a little bit more about that, about how did you get this one. But look at this. What are you seeing here? What you're seeing is 2001 4840 FFFF Charlie 012. This /64, the front part, that looks the same. So who do you bet gave that to me? Well, I bet you the router gave it to me, and that is, I bet, my network prefix. And I know that because it's my network. And so that's as I say. So you can start deducing an awful lot just from seeing that IP config. And so you can deduce how stateless autoconfiguration is working, and whether you have how you're getting multiple devices and so on. Yeah, let's look some more. Let's keep going. And so this is now we're coming back into today's world. This is something that I did relatively recently on my home network. And now you're looking here. One, we're missing those Teredo and ISOTAP interfaces. Right? Yeah, that again, we'll talk about that later. What are we seeing here? You're seeing per adapter, you're seeing my loopback adapter. Loopback, that's because I have Wireshark involved. So he's going to give me an NP cap adapter. It's kind of like a virtual adapter. And you're seeing a link local address for that. Well, grand, because I want to use that. But he doesn't need a global unicast because I'm only talking link local on that. But here's my Wi-Fi interface. This is my Wi-Fi. And here, who am I getting it from? Well, I'm getting it from Comcast. And so here, looky here, looks like I have 3 global unicast addresses. The same prefix here, 2601, whatever. And if I had to guess, I'm going to say maybe this one was given to me by DHCP V6. It's hard to tell. It's hard to tell now going from one to the other. But you can see here, this link local address, is this my MAC address? I don't know. I'd have to see, then we'd have to do an IP config all, which we can do in the next session. And we can start looking and see, can you tell, is this, how are you getting it? But you see here, this thing, let me highlight that some more. This thing, which we're calling the temporary IPv6 address, you'll see it. You'll see things as privacy address or temporary address. That's the one that changes all the time that I was telling you about before. And so we've got a number of addresses, and this one which changes all the time. And the other thing, what else do I know about this? We know that we're dual stacked. That is, I've got both an IPv4 and a V6 address. As I say, as we move on, pretty soon here in one of the later sessions, we'll take a deep breath and turn off IPv4 on the adapter and go V6 only. And then let's see what everything looks like. But let's crawl before we walk. So, okay. So let's talk about ICMP V6, because ICMP V6 is what's carrying all this stuff. It's used by Slack, also the other quote unquote protocols, the sub protocols, I guess, multicast listener discovery, router discovery, neighbor discovery. They're all going to use ICMP V6. And so you really want to get familiar with that. It's very, very different from V4. In V4, we're used to thinking, well, what's ICMP used for? It's used for communicating information about errors, basically. But no longer. You also have errors in ICMP V6, but there's a lot of important informational messages. Of course, your echo, ping, that we're used to, but your multicasting messages, your neighbor discovery messages, all of that is going over ICMP V6. So you want to really think about that. In fact, here's all the ICMP V6 informational messages. There's a ton of stuff. And so to me, what I try to do is, I don't want to get overwhelmed, so I'm like, okay, all right. I'm just going to learn 2 or 3 of these and then get those under my belt, and then I'll move on to learn some other ones. So let me show you what we're going to kind of think about. Ping, I think we got, although I think we looked at it even last time. What we're going to talk about is these. The multicast listener discovery ones. Here's my router solicitation, router advertisement. We'll talk about that. And we'll talk about neighbor solicitation and neighbor advertisement. Just don't even think about anything else at this point. If this is new to you, if you're an expert, then heck, why don't you come help me do some webcasts? No, I'm just teasing. But you know, as I say, one step at a time. So let's talk about neighbor discovery. So as we said, neighbor discovery is going to replace ARP. The basic, take a look at RFC 4861, and it's used in Slack. It's going to use these 5 Icmp V6 message type. Basically, what you're going to be communicating can be simply said. You want to tell people, the router wants to say, hey, look, people, this is who I am. The host wants to ask the router, okay, like, tell me what you know, tell me what we're supposed to do on our network, okay? Like, for example, what's our prefix? You know, how do we do things? You know, you clue me in. You're the boss of the neighborhood. Or you might want to have one host telling the other host. It's like your welcome wagon. I don't know if you guys remember when people used to do that. It's like you go over to your neighbor's house and say, hey, I've just moved into the neighborhood. This is who I am. Or somebody comes over to your house and says, okay, I see you've just moved in. Who are you? Or are you still living at the same house? You know, what's going on? Redirect, I'll just cover very, very slightly. Redirect is the same as we used to have in IPv4, and with the same flaws. As I say, I put it in here just because you'll see it. You'll see it if you go back and look at the RFC. But as I say, we won't go into it terribly. It has the same shortcomings as it did in IPv4. But as I say, let's not get crazy and dwell on it. So here's a neighbor discovery sequence, and let's step back a little bit and think about what we're saying. So first, how the heck do I know this is a neighbor discovery sequence? Well, what am I seeing here? What am I seeing? I'm seeing these addresses that are just colon. If we recall from our last session, the colon address is the all zeros address. That all zeros address is that I don't have an address. I don't have an address. I need to get an address. And so then let's go find an address. So where is this address going to? Well, so we have this destination address. And it's that's an interesting address. It's an FF02::1. Again, if we come back to our multicast groups, basically this is a multicast address to all nodes. And this is a very cute way of saying, look, this is the address I'm about to take. It's a neighbor solicitation. It says, I'm about to take this address. Does anybody else have this? Isn't that cute? And if somebody else says, yes, I have it, then you say, okay, well, let me try something else. So basically, duplicate address detection. And how are we seeing this? We're seeing this with a neighbor solicitation. So, yeah, interesting. We'll go through some more of the sessions. The next thing that we want to talk about is the whole discovery process. So how are we going to figure out, after we've got our address, what next? What do I do? So I'm going to start talking to my router. If people say, okay, there's nobody on this segment that has the same address, you go ahead and take that link local. But then you got to ask your router, and you say, all righty, so I want to get me a global unicast, because you guys are fine, but I really want to talk on the internet. What network prefix should I use? What's the MTU size? And then even more basic. Are we going to use DHCP V6? Are we going to use Slack or whatever? And then again, duplicate address detection. So this is all this is all the whole neighbor discovery process going on, and router discovery. So the router advertisement is extremely important for Slack. And so what does the router advertisement contain? All the stuff that we just talked about. What is their network prefix? What MTU size are we using? And so forth. And every once in a while, the router says, okay, well, I'm going to go ahead and send you router advertisement. You know, you don't want to send it like every second or something, or maybe you do, depends on how much you have. Every few seconds at least, you know, you want to send people. You don't want people to be waiting a ton of time. That's a decision you need to make, how long you want to have them. And they're going to be unsolicited router advertisements are going to go to that multicast address, FF02:1. What was that? All nodes. And everybody that gets this says, okie dokie, thank you. I'm going to go ahead and update my configuration now. And so I know. If you haven't gotten one in a while, say you've set up your router to do router advertisements every 10 minutes. Of course, nobody would do that, but say you've done that. And somebody joins in between those 10 minutes, the guy who's coming in can say, okay, you know, I need to do stateless auto configuration. I need an address, and I don't have a router advertisement. So I'm going to do router solicitation, and that will solicit what you want to get back. So that's a solicited router advertisement. The solicited RA is going to come back to him alone. It's going to come back to a unicast address, to the address of the sender. Again, that's why I said, let's go a little bit more into exactly what that router advertisement is. It's a very important packet, so we'll dwell on it a little bit. So again, if this is the destination address of the router advertisement, what do I know right away? Right away, I know if it's coming to FF02:1, this is unsolicited. And it can say use auto configuration. We're going to do stateless. This is our prefix. It'll say on the default router on this link. This is all valid for 200 seconds. What's our hop limit, and so on. So let's take a look. Let's take a look at this router advertisement packet. What do you know right away from this? You know your source address. Here is this link local. Destination is FF02:1. So what is this? Solicited or unsolicited? Unsolicited, because it's going to everybody. So here's your ICMP message type, router advertisement. What's our hop limit? 64. What's our prefix? Look, you've got this whole 128 bytes, but what are you looking at? You're looking at the first 64. So our prefix is 2001 4840 FFFF Charlie 012. So that's your prefix. Yeah. So there's a ton of information in that packet. Sorry. Okay. So the router solicitation is sent during Slack, and it's sent. It wants an immediate response. Remember, you say, you know, I need to come online. I haven't seen anything from you, so tell me something right away. You only send it 3 times. You know, because what if you don't have a router? You don't want to be like, yeah, you know, everything on my land is this person sending router solicitation. And if you don't have it, then you're like, okay, I guess we don't have a router. And so you forget about it. So here's the router solicitation packet. You can see here the source address. That's the link local address of your router. Very interesting. The link local address of your host. But what's the destination address? Is FFO2:2. So that is the multicast group, all routers. So what are we doing here? What we're doing is like, because this is my first time through the block, right? I don't know if we have a router or not. So I don't know what his link local address is. And so what I'm going to do is say, anybody who is in the multicast group, all routers, please respond to me. Yeah, again, that's quite cute. Here's the type 133 is the router solicitation. So if you get the router advertisement back in response to the neighbor solicitation, it'll go directly to that link local address. Or if you change the NIC card, whatever, then it'll go ahead and do that too. Here's a neighbor advertisement packet. That's a type 136. This is an interesting one. It's coming from the source address. That's a global address, and it's going to the destination. It's going to a link local address. Because isn't that kind of interesting? I've always wondered about that. Is why isn't the source address a link local? Because you are on link, right? Yeah, as I say, that's curious. But it's again, it is. You can tell it's a neighbor advertisement, of course, by the ICMP type 136. And you're sending it for neighbor solicitations are sent for a lot of different reasons. You know, as we saw before, you can do it during duplicate address detection. Is somebody have the address that I want to take, or to verify reachability. I was talking to you before, maybe to do file transfer, who knows what, you know, but are you still where I thought you were? Yeah, so you can see here, here's what we said before. Remember, these are critical. If you're seeing this thing, this unknown address going to the multicast all nodes, that with this back part being a host ID, you can see right there, that's my interface ID there. That's my interface ID. So what you're asking is, are you using the address that I want to take? Here's a neighbor solicitation packet to a particular address. Again, isn't that curious? Is that you're sending it to the global unicast rather than the link local. Yeah, interesting. But this is to a specific unicast address. So then this is set to verify reachability. So again, you know, I'll state again, the more comfortable you are with addressing, the happier you'll be. What have we done here? We've looked a bunch at multicast groups. What were we talking most of all about? FFO2:1, all nodes, FFO2:2, all routers. And again, of course, what we're using for all this is multicast listener discovery, to join groups and to leave groups. Because say you take a route, you bring a new router online, or you bring a new device online, last thing he's going to do is join the group FFO2:1. So here's the RSC. For multicast listener discovery, and here's as I say, interesting drafts that you might want to, or not drafts, RFCs that you might want to take a look at. Here's the message type. So you can do multicast listener query, which is what multicast addresses have people on there. Listener report. This is if I join a multicast group, say I join FFO2:1, then I'm going to say, yep, I'm a part of that. Or if you leave altogether, you'll do a listener done. So here's a multicast listener report. And so what is this telling us? So here's the source address, : and here's the destination address, FFO2:2. Who is that for? that is for all routers. So here's my, here's, as I said, and the other thing we should talk about too is the next header. So you'll see this, the multicast listener report being done there. I'm going to speed up a little bit because we're getting close to time. Another thing that's relatively new, you can tell if things are relatively new by the RFC number. If you're in the 8s, we're getting into relatively recent things. So now one of the things that people wanted to have is RAs when you're doing DNS configuration. So what that is going to do is allow V6 routers to advertise a bunch of DNS recursive server addresses. Let's take a look at that. Basically, the idea is if you're at your Starbucks, you don't want to reconfigure everything so you can do a global search. But you would, and if you used one of the big global DNS servers like 1.1.1.1 and so on, and you're inside your company, you wouldn't have your company resources available to you. And so what you can do is you can have DNS information but of course you can get DNS information during DHCP V6, but if you didn't get it from an RA, then you'd only have to have DHCP V6. So bottom line, you can get DNS information now in the router advertisement, and it's even more important. It's even more important when you start going to V6 only networks. Let me flip quickly to that, because then you can see it's a lot more interesting when you can look at the packet. So take a look here. Here's our router advertisement 134, and you can take a look here. You can see V6 option, which is showing you your recursive DNS servers, and so you can see this is what I want to search, and here's some more information on that. We'll take a look at a lot more of this in the lab. As I said, there's so much information to pass on, and you can see here the DNS search list being passed on here too. You'll get this entire presentation, and if you have questions, do let me know. Well, what can go wrong? That's where do we start, right? Well, you know, all the problems that you have with DNS can also happen with this. You know, you can do DNS spoofing, send people to the wrong place, and so on. There's a lot of benefits to stateless autoconfiguration. These are protocols you really need to know about, and you really need to have in your toolkit, and you need to understand. We'll be doing the lab on all this March 18th. Please do sign up for that. And if you have the next steps we're going to be taking is we started talking with folks who've signed up for the call for participation for universities and enterprises who want to collaborate with us. Stay tuned for more discussions. Just out of curiosity too, if people are deploying IPv6 and you know, would just like to start a conversation with us, do feel free to send me an email. You know, we are considering whether we can set up an ongoing group for those kind of discussions, because I think it's really needed and necessary. So last thing, IETF is next week. You can attend remotely. I would suggest you go to V6 Ops, if nothing else. IPv6 Ops, that's the IPv6 operations group. You'll learn a whole lot from the V6 Ops and the 6-man. 6-man is changes proposed to the protocol. Do please go to that. We just have a couple of minutes, and I'll take some questions. Okay, so let me see if I've got a few questions. Oh, it's a little I'll send, people want the link to the IETF meeting and my email. I'll send those onto the thing. Some of these other questions are about, let me see, they're about specific projects. And so, okay, there's one question, interesting. If we use static address assignment, do you need neighbor discovery? Well, you're going to need neighbor discovery for, yeah, that's the question, yes. You're going to need neighbor discovery for your link local, and you can get your static assignment from neighbor discovery also. You know, you don't need to get it from DHCP V6. You can, or you may, I mean, you don't necessarily have to get a temporary address if you use IPv6. We'll run through some of that on the lab. But anyway, let me close down now because we're getting to the end of time. Thank you so much for everything. I'll start recording. Please do send me questions on the email if you didn't get your question answered. We are happy to help you. And thank you